Okay. Now, file, new. I removed the hardware. عندك شحن؟
شو ابل؟ لا
مش ابل، لا عادي.
شو ابل؟
لا مش ابل.
احطه على الكمبيوتر طبعا.
مع الكيبل بشتغل بيه مع الهارد، هو كيبل كومن بشغل الاثنين.
جديد. منيح على WD.
ايه؟ جميل ده.
Remember I gave you one to check if it can be returned. Where is that one? But you still have it?
I think I will check now.
Can you get it? Check if you have it. Get it. تعرف هذا اللي بشيل منه.
هو هنا في دبي لا، بس في مصر اعرف كتير طبعا. هنا في دبي اني مول هتلاقي اني مول حافظ يا حبيبتي. I found it in
ضرب الهارد ديسك.
ضرب؟
بس فيه معلومات بدي اشيل منه المعلومات.
والله هو في واحد عندنا في مصر بيعمل في العاشر عندنا تخصيصا يعني بيعمل الحركه دي. If you can I can try with him، يعني ممكن تدوني على اشوفه لك هنا.
نفس الشيء ده بنقول هذا كام تيرا؟
ده 1 تيرا ولا 2 تيرا، استنى مش فاكر والله. 90 جيجا. لا ده 2 تيرا. 2 تيرا.
لا عندي كمان 2 تيرا.
شوفوا لي كده ممكن تدوني اظبطه لك. عندي شغال تبارك من الداتا بيطلع حاجه كلها بيظبطه يطلع الداتا بعد كده يفرمطه بقى. ممكن ينفع بعدها ممكن ما ينفعش، بس اهم حاجه اجيب الداتا بعد.
مش فارق معي بيظبط. المهم يشيل الداتا.
يشيل الداتا من عند حاضر.
إذا بقى شغل 11 سنة معلم.
يا لا بسيطة.
عندي مثل سيرفر صغير بالبيت، ملطش السيرفر.
اللي هو اي كلاود؟ اي كلاود ولا ايه؟
ونلطش الهارد درايف.
لا ادوني وانا هظبطه لك معاك. فايل نيو assembly. Automatically when we'll open assembly we'll open use this window to start import your new parts. Okay, all right. Now if you have a part like that, okay, and go again, insert components, and have another part like this. Now these parts are together in one file. You can move it freely, but this you can't move. Why? Because there is a rule. The first part will be automatically fixed, will be considered as a base. Okay? The first part you import into assembly will be by default fixed. By default. If you need to unlock the fixation, just right click and float. Okay? Float.
Then the other part is fixed.
No, other part already float by default.
So both are float.
Yeah. If you need fix will be fixed together.
How you block the components?
Right click float, right click fix.
No. How you block the component itself not to be in layer. Now once you are clicking on the item, it's showing the surface you are.
لسه انا جاي لسه في اوامر لل. Okay, if you find this fix F meaning the part is fixed. If you will find minus sign, part is float. Okay? You can select like that and move it. You can select from here by shift and the other, like computer, like normal Windows, like Windows.
You can shift both.
Yes, you can shift both, more than million of parts. Having the problem in this tree.
But now you can move.
No, you can't move because this is a free move, not a mechanical move. Okay.
So if you need to move both of them,
Why we need to move it? Because you have a relations you will do to be moved. This you have a relation of assembly. This not need to move because it's just a free move. Will not appear, will not find any animation, any specifications. You can't measure anything from this move. This just move. Okay. Right. Now we will do something as real example that we have. File, new, assembly. This one, a ring, okay. And we have another one. And have that. We need to assemble this three parts together into special condition, with a special condition. Now, see, this will be collapsed here and here, meaning I need like a toy children's, okay, and then I can move it
in any direction.
in direction. Okay, let's try together. Now, meet. See this sign? Yeah, like a hyperlink in softwares, Excel. Meet. Which I need to meet? This circle that defines the center of this part.
How you get the circle, or it automatically?
No, from the part I draw it for the sketch.
But you need to draw it.
Yes, as a sketch I draw it in the part of this. Okay.
If it's not drawn, what will happen?
No, you should draw. You should draw as a help, as a construction. Okay.
So you can center it.
You can center it. Yeah. Okay. Fine. Just click on the cylindrical face and this circle. Automatically you know that's what I mean. They are called concentric. See this? Concentric. This type of relations. This is a type of relations. We have multi relations: standard mates, advanced mates, mechanical mates. Okay? Standard mates like face on face. Okay? Point connected to point. Face parallel to face. If I have something like that, this face is parallel to face, but not mate, not coincident. Okay? Alright? I have a shaft and this concentric, the same axis. Okay? These are standard mates, all perpendicular. If I need this, perpendicular on this surface. Parallel, coincident, perpendicular. Okay? Parallel, coincident, perpendicular, and concentric. Alright? Advanced mate. We will see, because if I will explain now, you will understand. You should see with actions. And the mechanical mates, purely mechanical mates. Gears, screws, couplings,
Mm.
pulley. Now first I select this surface and this circle. This surface should be have a same center, and really it have a same center, okay, and concentric. Okay. Now see, you locked the circles together or the centers together, but still have a degree of freedoms, have a degrees of freedom. Okay, so I can move it here, here, here. Now we can first hide this or delete, at least now. So we need to fix one of them, rectangle or this pen. We can try to fix rectangle, right click, fix. So rectangle will not move. Now if I will move it, see, moving, but rotate about X and move in this direction because I haven't any relation yet, right? Okay, so I need to create a relation to stop this moving. Mates, if you will open, you will find each relation you did. Each relation has been created, will be found here, right? First, concentric. Yes, see, when you click on concentric, find what? Find which surface used for this concentric. You will find this surface with this circle. Okay. Also, if you will just mouse over, you will find this blue. This part with this part will identify to you which parts are connected to this relation. Because when you make a project, you will have a million of relations. Okay, now you can see, because you have just two. When you have 1,100 of relations, okay, you need to know which parts have connected to this relation. Just go mouse over, you will see these arrows automatically will select, right? Now, these main plans, top, right, front, like drawing, like part, the same. Okay, and you have also the origin, the same red point that we have before. Find this. Now I will get a new relation made, but parallel between this face and this right plane. But really, it's a haven't problem because it's parallel. So also I can move. Parallel, just parallel, haven't specific dimension. No, you can change to this distance. I need 20, no 20, 25. So 25 millimeters between this plane and this face. Okay, okay. Now find.
You can get the plan next to the unit.
Yes, yes, you can change.
You can move
No,
the
no,
plan.
you can move the unit to the plane.
Next to the plan.
Yeah. See, now you can't use your mouse. You can't move. Just you have 1 degree of freedom. Only
Rotation.
rotate. Okay. If I need to create another one,
Copy.
okay, like copy paste here, you can use pattern Do you remember pattern? Circular pattern.
The body now?
Okay.
So rich that it is fixed already on the direction left and right, it is only rotating. Now we need to fix the rotation angle.
Yes, you can fix, but now we will have copy it another side
Yeah.
and bring it assembly into these plans. Okay. Now your main port should be referenced by these plans and the origin. So if you remember what we said it first lecture, we said that you should have in your part when drawing, you should use the origin and reference plans. Okay, do you remember that? Remember what we said first lecture when we said that your model should be have a reference with this origin. Yes. Why? Because this situation. Now, if you see right, top, front, but right, the model is far away from right, and front and top. So we need to middleize it. So float, change it to float. Okay. Free move. Okay. You can arrange if you need to arrange the parts. Just drag P01, P02, 03, 04. Now, if you will select on this arrow, you will find that this part already has been drawn in the middle of origin. Okay, so we need to constant this front plan with this right plan. Okay, will be constant. So all body will be moved at the middle of environment. Let's see how. Meet, same order. Just click on your right in the assembly and the front of the part. Locked. Yes. Front. Right. Locked. Top. Locked. Now you'll find your main part has been locked from each side. So now not fix it, but you can't move. Not fix it, but you can't move. Okay? We will change this distance from 25 to be suitable with this distance, 10. Like that. Okay. This will help you to copy another one on another side with mirror. You can use mirror because if you have a 10 from here and you need another one with a 10 from the same side, you can. Linear component pattern menu, you will find something called mirror component. The same icon in a part, but in a part mirror feature, mirror bodies. Here you haven't feature and bodies, you have a component. Okay, mirror component. The same procedures. Select your plan, which will be the mirror plan, and model. Just okay. Now has been mirrored and working together because mirrored like a copy. Okay, working together. If you will go to concentric, you have to get something called lock rotation. Lock rotation, this means that you will lock the rotation, a free rotation of the part. Concentric has been changed its icon. Its icon changed to this sign. Right click, edit, feature, no lock, change it to this icon. Also, if I need to copy another one like that, right click, or sorry, left click on the component and control on the keyboard, control, just drag it out. You will create a copy. Remove your hand.
Training.
Okay. Again, left click, control, still press control, left click, still press left click and control, just drag, finished. Copy. Without any mates, just copy. You can make it with any relation you need. Okay, just copy. Also, you can do that from here. Just select on the part, the same, control, copy.
Like in straight through select some item and we press alt and we will copy.
Yeah.
That's
That's fine.
just control difference.
Yes. You can do the same. Mate this with this. Okay. Need to control side. You can do this plan of this component. Mate the plan of new copied component with a plan of all the copied of all the component. Working physically like real, no difference. Okay. All right. Save and save. Now your component is okay. All right. If I need, when I move this, I need this always horizontally. Always horizontally. Mate top with this top, but will be parallel because I need to move. Will be parallel. Will not inclinate it, but will be horizontally, but parallel, always parallel. Okay, you can move, but always parallel to this plan. See? Always parallel. You can rotate it. All right? Okay. Now, if you need to check when I make this as a magic, penetrate, okay, this part doesn't feel the other parts. This part can be go penetrate, so I need to get physical motion. When I come with mouse, tack, stop, tack, stop. If you need to do that in 3D Max, you have a plugin called Havoc. You know Havoc? Havoc in 3D Max makes the same, but only make for animation. That he feel surface, okay, and get action and reaction, okay. But here it's very easy. Just we go to move component. The free drag, no, we have it the free drag. We have physical dynamics. Physical dynamics. Not standard drag, no, physical dynamics. And we will select our components that we apply physical. Why all components? Why not all components? You can use all components. But when your assembly will be larger than 20 components, okay, and we'll get it all components, will take a lot of RAMs, a lot of memory, when processing, maybe hang. Depend on your computer performance. Okay, so now I have only collision, really collision between this arm, and this component. Not need this one in my test. Okay, if you not need, it's okay. Also, you can this and this only, because when this stop, this automatically will be stopped, because they are the same dimension, okay, and the same point of contact. Okay, just okay. There is some drag and start with dragging. Stop. Can't go more. Can't go more. Now it stopped. Okay. If you need alarm, you can get collision detection. See? When collision, change color in impact.
Between collision
No physical dynamics. No stop, non-stop.
and standard.
And standard haven't any sense. Just move.
Okay. Collision. It shows
Collision.
the change color.
Yeah, change color.
But we can move. It shows color, but we can move.
Yes, you can move, but the color will be changed. Yes, tick. Tack.
Go more.
Change the face.
More up, more,
Tack, change the face.
more. Go down. Wait. Stop. The bottom of this is also okay. Now the other one.
All faces. See O. See the O. Face. When collect, done. Have a collision between O surface and it's very precision, because we calculate the mechanical calculations, its actions. We take a very expensive decisions. Depend on these actions. All right. Okay. So I will stop assembly today, because tomorrow we will continue with mechanical. We will draw the fully mechanical part with gears and something like that. Okay. I need from you just revision, just make review please before tomorrow, because tomorrow will be concepts of mechanical, and tomorrow will be mechanical concepts. Okay, you should review all previous videos. You can collect all this in one model. You can do each model you want, make implementation, okay, try to work. And I need that I said to you first lecture at the morning. I need from each one paper, all questions you need, all queries you need. Please give me before starting lecture, because we can do 30 minutes. I haven't a problem to make a 30 minutes over to answer on your questions, okay?